Good morning. Today we will complete the lesson number 3. It's called the main group in the modern periodic table. We studied the last lesson, the first group, 1A, that's called alkali metals, and we study some properties of the 7A group or 17, that's called halogen. Today we'll complete the properties of 7A group halogen. And we'll talk about the inert gases group that's called 0 or 18 in the modern number. This is the modern periodic table. We study the group 1B or 1 in the modern number. That's in block. All group 1B are alkali metal except the hydrogen. That's called or it's non-metal. So all group 1E are metal, they're called alkali metal except the hydrogen. And this is halogen group 7E or 17, and this is the noble gases and inert gas group 0 or 18 group. We study that the alkali metal group 1E starts from lithium, sodium, potassium, rubidium, cesium, and francium. All of them are natural, found in nature, except francium are artificial prepared. Group 1E called alkali metal. It's located in the maximum left side of the modern periodic table. They are located in S block. All of them are metal, that good conductor of heat and electricity. All of them are solid state and have metallic cluster. Most of them low density. And when we arrange the density from the smallest to the largest in the group 1A, lithium has the least density, then potassium, then sodium, then rubidium, and cesium. Lithium, sodium, potassium has low density because they are float on the water surface. But rubidium and cesium has larger density than water, so they are sink in the water. The chemical properties of 1A group or alkali metal, all of them has one electron in the outermost. So we call it monovalent. Why we called it monovalent? Because it's metal, so it tends to lose the outermost valency electron that's have one, so it's called monovalent, and it changes to a positive ion, carry one positive charge. And all of them very, very active element. Can't leave it in the air. It will react instantly as soon as it's exposed to the air. So we kept it under liquid that doesn't react with the air in it, that prevent reaction with the air, like kerosene and paraffin oil. Why we kept it under surface or kerosene or paraffin oil? Because it prevents its reaction with moist air, moist meaning the water vapor in the air. Sodium and potassium kept under kerosene, and all of the alkali metal kept under kerosene, except lithium kept under the paraffin oil because it floats in the kerosene. When it floats in kerosene, that is dangerous because it will react because its surface will expose to the air. So we keep lithium and paraffin oil because it's sink in paraffin oil. But all the alkali metal kept under kerosene surface. Because they are very, very active elements, what happened to its activity in the group as we moving from up to down? We found that the chemical activity increased as we moving down. So the lithium had the least activity, then sodium, potassium, rubidium, and cesium are the most active element for alkali metal in group 1A. Why it's very active element, or why its activity increase as we moving down? Because as we moving down, the atomic size increase, so the reaction between the nucleus and the most electron. This is the attraction between the positive proton and the outermost electron. As the size increase, the attraction force become weaker and decrease. So it can lose the outermost electron more easily. So why its activity increase as we moving down? Because when moving down, the size increase, so it lose the valence electron more easily. And the cesium are the most active metal or alkali metal. Why? Because it has the largest size, so it loses the valence electron more easily. And when we make a comparison between sodium and potassium reaction with water, we found all the alkali metal when react with water, what happened? Formed base or oxide or alkaline solution, and hydrogen gas evolve with pop sound and make a fire because it react as soon as exposed to the water, and this reaction are produce heat, so we see the fire that happens produce heat. So when sodium react with water forming sodium hydroxide alkaline solution because it had hydroxide group, and hydrogen gas evolve on both sides. And also potassium reacts with water forming potassium hydroxide, and the hydrogen gas evolves with both sides. But we see the potassium reaction are more reactive or stronger than the sodium. Why? Because the sodium and the potassium are more atomic size, so it's more reactive than the sodium. Why we call it alkali metal? Because it forming alkaline solution when we react with water. Why the sodium fire we can't put out by water? Because the sodium reacts instantly with the water and evolves the hydrogen gas with pop sound. This reaction produces heat, so this is fire happen. So we don't put out by water because when we put water, the fire increase because it reacts with water instantly. And all the alkali metal are monoatomic. Monoatomic, that means its molecule consists of one atom only. This is about group 1A or alkali metal. But group 7A or 17 that called halogen located in the map in the right side before the inert gases, located in P block. Start from chlorine, bromine, iodine, and acetylene. All of them found in nature except acetylene, which are prepared artificially. All of them are non-metal and bad conductor of heat and electricity. Chlorine found in gaseous state. Bromine are liquid state, but iodine are solid state. All of them have 7 electrons in the outermost, so it's called 7A group. So it's called monovalent because it needs 1 electron to complete the outermost, so it gains 1 electron. So why we call it monovalent? Because it gains 1 electron in the outermost and change to negative ion, carry 1 negative charge. So the alkali metal and the halogen are monovalent, but the alkali metal lose 1 electron, but halogen gain 1 electron. The the halogen, all of them diatomic. Diatomic, it means its molecule consists of 2 atoms, called diatomic, and they are active. They are has chemical activity. But the activity, as we moving down, it decreases. That opposite to the alkali. Alkali, when we moving down, the activity increase. But the halogen, when we moving from chlorine to acetylene or iodine, the activity decrease. So the fluorine is the most active halogen, and iodine the least active halogen. So when why it's called halogen? Because when it react with metal, it's forming salts like potassium. When it react with bromine, potassium is metal, react with halogen bromine, forming potassium bromide. It is false because it consists of positive and negative ions. Potassium are positive metal, bromine negative non-metal. So the form salt uh, called potassium bromide. So why we called it halogen? Halogen meaning it's forming salt when the active is done. As we see, the activity of fluorine is the most active, then it's decreased as we move to the iodine. That's me. Fluorine more active than chlorine, and chlorine more active than bromine. Bromine more active than iodine. So when any halogen react with salt that has another element has less active than it replaces the halogen. So when halogen, the act of salt that contain halogen less active than it replace and take its place. So when fluorine before the iodine and the bromine, the chlorine more active than bromine. When the chlorine reacts to the salt that contain bromine, it replaces the bromine and take its place as this reaction happens. So when chlorine reacts with potassium bromide, salt of bromide, it replaces the bromide and form potassium chloride and bromine gas or bromine left in the reaction because the bromine is less active than chlorine. When the bromine reacts with potassium iodide that has less activity than bromine, it takes its place, forming potassium bromide and iodine gas forming. But when the chlorine, when the bromine reacts with salt of chlorine, like that. When bromine reacts with salt of chlorine, right? Potassium chloride. What happened? Or the bromine replace the chlorine? We see its activity. As we see, with the more active chlorine or bromine, the more active is chlorine than before bromine because the activity decrease as we move down. So bromine can replace chlorine? No, because it's less active than it. So when bromine react with potassium chloride, bromine doesn't replace the chlorine because the chlorine more active than bromine, so no reaction happens. So when halogen reacts with salt of halogen, but less than it in activity, we can it can replace it. But when the halogen reacts with salt with another halogen that when halogen reacts with salt of halogen that has less active than it can replace it. But when the halogen reacts with salt of halogen that has more active than it, so doesn't reaction happen and can replace So this is group 7A or 17 group. What about the noble gas? Noble gases are called ethene or zero group. Why it's called zero? We will talk about it. It's found or located in the maximum left side of the table. Sorry, it's maximum right side of the table. So the noble gas or inactive gas are or inert gases are located in the maximum right side of the table. It's located in the B block, like hydrogen. It's part of helium, then neon and argon, krypton, xenon, and radon. All of them are gaseous states. All of them has 8 electrons in the outermost. So it's called zero group or it's valency zero. Why it's called zero group? Because it's valency zero. Zero, it's meaning it doesn't enter any chemical reaction. Why? Because the outermost contain 8 electrons. That is the largest number of, or the maximum number of electrons that could be in the outermost. So it doesn't need to enter chemical reaction. It doesn't gain or lose or share with another element, so they are called zero group. So why is valence zero? Because outermost saturated. Saturated meaning it's completely filled with 8 electrons. All of them are gaseous. All of them contain 8 group in the outermost except helium. Helium, which has one energy level K and K saturated all completely with 2. So all of them have 8 electrons outermost except helium has 2 only. All of them are inactive. We called it inactive because it outermost completely filled with 8 electrons, so it doesn't react with any other metal under normal conditions. All of them are monoatomic. Monoatomic meaning its molecule consists of one atom only, one element only. Its molecule consists of one atom or one element only. This is about noble gas. We use some element in our life, in some manufacture. We will talk about 4 of them. Number 1, sodium. Sodium are metals in the alkali group 1A, but when we melt it, it changes to liquid. Why we use the sodium as a liquid state? We need to use it in the nuclear reactor. Nuclear reactor is having nuclear reaction in it. Why we use a liquid sodium in the nuclear reactor? Because it's good conductor of heat. Call it metal. And it transfer heat from inside the nuclear reactor to outside the nuclear reactor. Again, the nuclear reactor needs liquid sodium because it's good conductor of heat and transfer heat from inside the nuclear reactor to outside. Why? This is heat energy outside the nuclear reactor that heating the water that's used in generator or generating electricity. We generate electricity by heating the water. Water are moving a machine called turbine and generator to generate electricity by evaporate the water. The water is moving the machine to generate electricity. So the nuclear reactor use liquid sodium because it's good conductor of heat and transfer the heat from inside the reactor to outside it to use the end reduce water vapor to generate electricity. The nuclear reactor generate more heat because the nuclear reaction produce large heat. Okay. Second element are cobalt. Cobalt are transition element. Transition element, that's element is found in G block. Found in G block. This is transition element like cobalt, but another derivative of cobalt, cobalt 60. The original cobalt has atomic number The original cobalt, as we see, has 27 atomic number, but the derivative of cobalt 60 are called radioactive cobalt. Radioactive meaning another type of cobalt, like isotope, but very, very active. We prepared it. This is called transition element because it's found in the block. We use cobalt 60 radioactive in food preservation. In food preservation. We use the cobalt 60 in food preservation. Why the cobalt radioactive used in food preservation? The radioactive, it produce rays. It comes because it prepared artificially. It produce ray. From this ray, gamma ray. Gamma ray used to killing the microbes in the food, so we can preserve it a long time without it can be rotten. Without rotten. Okay, so the cobalt 60 radioactive used in food preservation. Why? Because it emits or gives gamma ray that prevents the reproduction or growing the microbe cell in the food without any effect in human. So we can preserve it long time without rotting of the food. Silicon. Silicon is metalloid. Metalloid meaning semi-metal between parts of metal and non-metal. Silicon are used in manufacture of slide in the electronic device like computer and transistor. The slide that we found in mobile computer made of silicon. Why? Because the silicon is semiconductor. Because it's semi-metal, it also conducts heat and electricity, but semi. Yeah, not all the time it conducts heat and electricity because it has semi-metal. But when it conduct electricity or heat, when it uh, close to electricity, when we put in electricity. So the silicon are semi-metal, metalloid. So it's semiconductor that has ability to conduct electricity within its temperature. So when we connect the device with electricity, the electricity generating heat. So the slides are heated. When it's heated, um, it generates electricity. Again, so the silicon slide that found in computer or electronic device generate heat when temperature increase. Temperature increase when we connect it with electricity. When we turn off the machine, it will cold, so doesn't conduct electricity in this case. So the silicon used in making the slide in electronic device like computer and transistor because it's semi-conductor of electricity that has ability to conduct electricity according to its temperature. Number 4, nitrogen, the liquid nitrogen. When we pressed the nitrogen, it changed to liquid. Nitrogen is non-metal, but the liquid nitrogen, we use it to preserve some type of cell like cornea of the eye. Cornea of the eye is part of the eye that we need to preserve it. We're using it later in any in the patient that need cornea. So liquid nitrogen used as a liquid to preserve the cornea of the eye because it's kept liquid to minus 196. So it doesn't boil or change to gas until this temperature. So it keeps liquid at this temperature, or it kept and below this temperature it kept liquid. Above this temperature, it changes to gas. So we use it to preserve the cornea of the eye because decrease boiling point to minus 196 degrees to become liquid at low temperature, so it preserves it. This is the uses of this element. We study the 3 main groups, 1A, 7A and 18 group, alkali metal, halogen, and noble. We will answer some question. Lithium are the most active metal in 1A. That's false because the lithium is the smallest active. So because the activity increase as we moving down. The cesium is the most active metal or alkali metal. Chlorine can replace bromine in salt solution. Right. Why? Because the bromine is active than chlorine. Halogen is from S block. No halogen in the B block. Magnesium slide used to manufacture of electronic device. No, it's silicon slide. Um, the valency of alkali element is monovalent. Monovalent. Is the alkali metal which located in the period 3. Period 3, it has free energy level. Free energy level is sodium. Sodium react with what to produce sodium hydroxide? Sodium hydroxide alkaline solution. When react with water, 2H2O. Potassium when react with water also formed alkaline solution potassium hydroxide, KOH. And hydrogen gas evolved with pop sound. You can react with bromine that not replace it. React with bromine to produce potassium bromide. It's potassium. From this reaction, potassium reacts with bromine forming salt, hydrogen. When sodium reacts with chlorine, also forms salt because it's metal and non-metal, sodium chloride, NaCl. When sodium bromide reacts with chlorine, the chlorine can replace the bromine. Yes, because the bromine less active than chlorine, so it produces sodium chloride. 2NaCl plus bromine are forming in the reaction. We are 2. Bromine react with what to produce potassium, bromide, and iodine. We found that iodine are formed in the reaction, so it reacts with salt of iodine, potassium iodide. So when potassium iodide reacts with bromine, iodide reacts with bromine, it replaces it because of bromine more reactive than bromide. Bromide react more reactive than iodine, so it replaces it. This is the action happen. When chlorine reacts with potassium bromide, it can replace it or not. The bromide less active than chlorine. So chlorine can replace it. So the formula potassium chloride plus 2KCl plus bromine are released in the reaction. So the chlorine replaces bromine in its salt solution because more active than it. Please we answer the question or the equation. You will answer also this question. Question, yes. Okay, this is opposite figure. We see X, Y, Z, L, M, but Y has 11 atomic numbers. So 11, so it has two in first energy level, second has 8, third has 1. 1, so it's 1 electron outermost, so it's alkali metal. So the name of this group, alkali metal. Alkali metal or 1A group. What is the valency of this element? The valency is monovalent. It has one electron outermost. What is the importance of Y in nuclear reactor? Y 11, so it's sodium. Sodium is used as because the heat transfer the heat from inside the reactor to outside the reactor to use water vapor used later in generate electricity. Calculate the atomic number of Z. Z is located after it in the same group. We study in first lesson. In the same group, the atomic number increased by 8 electrons. But in period, each element increased by 1 electron. So the Z contain 11 plus 8, so it contains 19 atomic number because when we're moving to the same group, increase the 8 atomic and 8 electron than the previous element. Mention the symbol of element at least the atomic size. Atomic size in group 1A, we know it's X because as we move down, the atomic size increases. The most active element, it's M. This is lithium, sodium, potassium, cesium, and francium. So the most active, as we see, is we starting with lithium. Lithium, sodium, potassium, rubidium, and cesium. So the M is cesium. Okay. So the X is the small size, but M is the most active because the activity increase as we moving down. So the M is the most active, like cesium. This is all about today. The next session we will start the fourth lesson. It's called about the water.